Let's solve a problem of related rates. The problem says, for a certain company, the relationship between revenue R in millions and number of employees N in thousands can be approximated by the equation phi R squared equal 957 NQ. In 2012, the company generated revenue of 35 billion, had 183 employees, and was adding employees at the rate of 12,000 per year. Find the rate of change of revenue with respect to time that year. So this is an example of a problem of related rates. We are going to find the rate of change of one of the variables, and we have an equation. So to get the solution of a problem like this, the first thing is starting from the equation. So the equation that we have, phi r squared equal 957 n cubed. This equation gives me a relation between the variables, and we're going to find a relation between the rate of change. Sometimes in a problem this is not given. You need to find it in the mathematics you know. In this case, it's given, so we are happy. Here we have the relation between the variables, and now use implicit differentiation to get the relation between the rates. So I'm going to differentiate every term I find in the equation. For example, here is phi r squared. Anytime that we have a function that is not a function of the time, is not a function of the independent variable, use the chain rule. I get the derivative of phi r squared. It will be phi times the derivative of r squared is 2r, but I need to multiply by the r dt. So let's do it. So it will be phi times 2r, that is the derivative of a variable to the power 2. We get 2r to the variable to the power 1, but I multiply by the r dt. And at the other side, it will be the same. This derivative of n cubed is 3n squared, so it will be 957 multiplied by 3n squared dn dt, because I need to multiply by the inner function derivative, by the derivative of the inner function. So this is the constant multiplied by the derivative of the function. This is 3n squared dn dt. So let's simplify this. It will be 10r dr dt in this case. Here will be 957 times 3, so that is 2871 n squared dn dt. Because the question is find the rate of change of revenue. So we are going to solve this for the r dt. So the first step is using implicit differentiation to get a relation between the rates. So here we have a relation between the r dt and the n dt. And now that I have this as a second step, solve the equation for the rate of change you are looking for. You are looking for the rate of change of revenue. So will be the r dt equal 2871 n squared dn dt divided by 10r. You can type it in this way, yeah? 2871 n squared divided by 10r multiplied by the n dt. So we have a formula for the r dt. At that point, when you have the r dt, when you have the related rate that you are looking for, you are going to take a picture of the problem in one point of time. Usually they are asking this rate of change in one point of time. And the point of time that they are looking for is 2012. So what happened in 2012? So the value of n, what will be the value of n in 2012? What will be the value of r? What will be the value of the n dt in 2012? So I'm looking at that moment the pictures of 2012. What was the value of everything at that point? It must be given in some part of the problem if this problem has solution. And let's read what happened at that point. The company generated revenue of 35 billions. So the revenue R was 35 billions in 2012. This is part of the picture of 2012. The number of employees in 2012 was 183,000. So at that point of time, N was 183,000. And was adding employees at the rate of 12,000 per year. So the entity, the rate of change of the number of employees was a positive 12,000 per year. So we have the value of everything. So in this case, the problem says that in 2012, R is 35 billion at that point of time. N was 183 and the NDT equal 12. Look at that, I put N equal 183 because they told me at the beginning that the employees, the number of employees N is in thousand. So this N that is using in the formula is in thousand. So if there were 183,000 employees, so they will be N equal 183. The same here, if I noted that R, the revenue was 35 billions, by R is in millions. 35 billions is actually 35,000 millions. So R will be 35,000. So the value, so they give me here the value of R, but you need to take into account that it was in millions. That R that I'm putting here is in millions. So if this is 35 billions, so this is actually 35,000 millions. So R will be 35,000. So you have a number to put here, you have a number to put in N, so you have a number to put here in the NDT. So you have actually three variables. N is a variable, number of employees. R is a variable that at that point have a value. And the NDT, the rate of change, is a variable. And at that point of time, it was 12,000 per year. And the NDT. So the NDT will be 12. Remember that N is in thousand. So the N, so this is 12,000 per year, so then the NDT will be 12. This is the derivative of the number of employees. So the number of employees is in thousand, so the NDT will be also in thousand. So there will be 12,000. It's actually number 12. So okay, make a substitution of everything in the formula. So we have then that the RDT will be 2871, and here instead of N I'm going to type 183, instead of R I'm going to type 35,000, and instead of the NDT I'm going to type 12. So that will be the answer. So use your calculator and you will notice that the answer is 3,296.5. This is the change in the revenue, and this change in the revenue will be in millions dollars, so it will be the same unit that is given R. It will be that was given in millions. So 3,296.5 million of dollars. And because this is a positive value, we can say that the revenue was increasing at a rate of 3,296.5 millions per year. This is around 3.3 billions per year. So the revenue at that time was increasing around 3.3 billions per year. Okay, so that's finished my explanation of this problem. As you say, first is divided actually in three steps. First, use the implicit differentiation to get the relation between the rate of change of the variables. Then solve the equation for the rate of change that you are looking for. In this case was the rate of change of the revenue. And finally, substitute the value of the variables in the equation that you have found for the values in one moment of time, the moment of time of the question. In this case was in 2012. Okay, I hope you have found this explanation useful. See you in other videos. Thank you.